So I was discussing in the last video, okay, about the branch part. Okay, that is in the branch part. If you see, you got minus 12 as the immediate value. So how you are going to write the minus 12 here? You have to understand that here the branch is split in this format. First you will write, it is actually 13 bit, so you have to represent in 30 bit. Okay, here the branch is represented in 13 bit, and in the immediate here, first I will write 12, then 10 is to 5 in the first 7 bit, and the later I will write 4 is to 1 and 11 in the next 5 bit. So that means if I have minus 12 in the first I will write the 12 would be what? 0 0 1 1 0 0 0 0 0 0 0 0 13 bits. I will write one more 0. Okay, now one's complement of this would be what? One's complement of this would be 1 1 0 0 1 1 1 1 1 1 1 1 1. Add 1 to it. When I add 1 to it, I will get what? 0 0 1 0, then 1 1 1 1 1 1 1 1 1. So I get the 2's complement. Now I got minus 12. Now how I am going to split is that this is my 0 1 2 3 4 5 6 7 8 9 10 11 12. In branch I told you the immediate we have to write it in 13 bit. That is why I write in 13 bit. And here first 12 bit I will write. In the first 7 bit what you are going to write? First this is how the splitting. So this is 7 bit splitting, this is 5 bit splitting. First I will write the 12th bit, that is 1. Then I have to write from 10 to 5, that is 10 to 5 is this. So that I will write 10 to 5. That would be what? 1 1 1 1 1 1. So this would be my 7. That I will write here. Now this is the splitting of the next 5 immediate value. This first 4 is to 1 means 4 to 1. That is this value. That is 1 0 1 0 is 4 is to 1. Then I have to write 11. 11 is here. That is this 1. I will write 1. So this would be my 5 bit splitting like this. This is how you have to write the splitting in our B type. Then normally RS to RS1, if it is branch equal to, it is 0 0 0. Fine. This is how then you will write the machine language format. Then you have to understand how this basically works. That is their single cycle processor, how we are going to implement it is what we are going to understand here. So to implement it in single cycle processor, I told you through the diagram. I will teach you. First of all, let me take the diagram. Okay, here if you see ALU control, here what happened is that we are basically, first we do is that x4 and x4 we will read. So x4 their value we have going to take, and I am taking it to my ALU SRC and see. First see, I have to take their value into the ALU SRC. That means I have to subtract it. ALU control is 0 0 1 because I am subtracting it. So when I subtracted it, and here there is a multiplexer, that is ALU SRC. Now that value would be what? 0, because I am taking the value from the register. Okay. Now if I get here 0 means, if I go, when I subtracted here is 0 means my 0 flag is 1. That means I got a 0 flag. Okay. Now the 0 flag is 1. Now if I got a 0 here, if I get a 0 here, my 0 flag is 1. Now if my 0 flag is 1, PCSRC would decide here. PCSRC would decide whether I have to take from here the next instruction like this, or whether I have to take the next instruction in the branch. That is, according to the immediate value, I will extend that immediate value, and immediate value plus the current instruction, immediate value plus the current instruction would give me what? Now immediate SRC is what? 1 0. Why immediate SRC is 1 0? Immediate SRC is 1 0 because 4 locations are there. Here my immediate is divided into 4 locations, as you have seen. Immediate is split into 4 locations. Have to combine them. That is why it is 1 0. Fine. Now I will add that, then I will get the PC target. Now PCSRC is calculated using what? PCSRC is calculated using 0 and branch. branch would be always 1. Branch would be always 1. So it is decided by the 0 flag. If you go to 0 flag, then it is 1. That means my PCSRC is 1. If my PCSRC is 1, then my next I have to jump to that instruction. If my 0 flag is 0, means I didn't get a 0 here. That means it won't be PCSRC value will be 0. That means I will do the normal execution here. That is what it means. Otherwise, I am going to do the normal execution. So here if you do, why I am taking the immediate SRC? In S type I took the immediate SRC 0, 1 because only 2 locations are there. Split it into 2 locations, we have to reassemble them. But here my branch, my immediate SRC is split into 4 different locations. So I have to take from these 4 different locations, I have to combine them to get the 32-bit. So that is why my immediate SRC is what, when I am extending it, I needed to use the immediate SRC value 10. Fine. In load, only one place the instruction is there. That is why my immediate SRC is just 00 in my load case. Fine. This we have understood. And my ALU control is 001 because it is subtraction. ALU SRC is 0. Why my result SRCs don't care? Because we are not going to that section. But memwrite and regwrite is also 0 because we are not writing anything in the register, nor we are writing anything to the memory. Now one important thing that you have to understand is that my ALU SRC is 0. Why my ALU SRC is 0? When ALU SRC is 1 is what? When my source B is coming from the immediate. But here the source B is not coming from the immediate, so my ALU SRC is 0. When would be my result SRC 1? Result SRC is 1 when I am taking the data from my memory. Otherwise result SRC is 0. Result SRC is 0 when I am taking the value from the ALU. Branch is always 1. Okay, PCSRC is what? Branch and 0. And 0 means whether you get a 0 flag or not. That is decided there. Fine. So this is how the final single cycle data path is. This is about the data path. So in the data path, from the instruction, we have the opcode function 3 and function 7 value and also the 0. That is, these 0, opcode function 3, function 7 basically decide my main full control. The PCSRC control, the result SRC control, the ALU, the memwrite, the ALU control here, ALU SRC, immediate SRC, regwrite. All these are decided by, first by the 0, then decided by the opcode function 3, function 7. So this is how the control unit would look. So guys, I would suggest you to learn this control unit also, because this is how the control unit actually looks here. So I want you to learn this control unit also. The single cycle processor, how the control unit look. You have this control unit, opcode, whether it be function 3 value, function 7 value, right, the 0 is there. All other control unit are coming here in the other side. Fine. So this you have to learn. Then I would recommend to learn this diagram also. That is our result SRC, memwrite, regwrite, ALU SRC, immediate SRC, ALU control. ALU control. Okay, here if you see, this are here. Now my PCSRC is decided by what? My 0 and branch. So branch is coming from here. This decide the PCSRC value. Now opcode is here. From the opcode, now function 3 and function 7 here is used for the doing the operation. Now ALU decoder has this ALU control. Fine. Then, so this diagram, okay, this diagram you have to learn function 3, function ALU, where you are dividing it furthermore. Main decoder and ALU decoder. You are going to divide in such a way that you have a main decoder, you have a ALU decoder. Like that you will be dividing that. Now, so you have main decoder and ALU decoder. So how the diagram comes? You have the main decoder, you have the ALU decoder. So this opcode, which is basically has a connection here. Okay. Then we have the function 3 value, function 7 value in the ALU decoder, which would give this ALU control is here. ALU op is coming here. Fine, ALU controller is also here. Now, from the branch here, we are going to add it, the 0 flag. Then you get the PCSRC. Then you have the memwrite, the main decoder, regwrite you have, ALU SRC you have, result SRC you have, immediate SRC is also here, so you have to write the immediate SRC. So these things you have basically. Fine. Now the next thing that we have to learn, so this is about the single cycle. Okay, main things about the single cycle is done. So till now the half of the module revision is basically done. Now we have to talk about the pipelining part. Fine. So in the next revision section we will be covering starting from our pipelining. Okay, thank you.